Dear students, today we discuss the Lagrange's mean value theorem. If the function f of x is continuous over the closed interval a comma b and is differentiable over the open interval a comma b, then there exists at least one value c in the open interval a comma b such that f dash of c equal to f of b minus f of a divided by b minus a. So proof of this theorem is, so let us define a function. So let us define a function. So it is pi of x. So pi of x equal to f of x minus k into x. So k is appropriately chosen. Since f of x is continuous, because the function f of x is continuous in the closed interval a comma b and is differentiable over the open interval a comma b. Since f of x is continuous in closed interval a comma b and differentiable, the function is differentiable in open interval a comma b. So we have pi of x is also continuous over open closed interval a comma b and is also differentiable in open interval a comma b, because pi of x is defined as f of x minus k into x. So pi of x is also continuous in closed interval a comma b and is also differentiable in the open interval a comma b. So now apply the Rolle's theorem. Now apply Rolle's theorem for pi of x, because pi of x is continuous in closed interval a comma b and is differentiable in open interval a comma b. The proof and the statement and proof of the Rolle's theorem is in a video. The video link is in the description. So pi of x. So the third condition of the Rolle's theorem is pi of a equal to pi of b. Pi of a equal to pi of b. From the equation 1, f of a minus k into a equal to pi of b is f of b minus k into b. So f of b minus f of a, here k into b minus k into a. So k is taken as common out, k into b minus a equal to f of b minus f of a. So k is, keep as it is, f of b minus f of a divided by, it is b minus a. So now the third condition of the Rolle's theorem. So again, thus for this value of k, the third condition of the Rolle's theorem is also satisfied. Hence there exists one value c, so that is belongs to a comma b such that is pi dash of c equals to 0. Again from 1, f dash of c minus k equal to 0. So that is f dash of c equal to k. So f dash of c, so what is the k value? So this is a k value, so taken as it is equation 2. So k f of b minus f of a divided by b minus a from 2. So equation 2. Hence the theorem is proved. So this is the proof for the Lagrange's mean value theorem. So now we have to move on the Cauchy mean value theorem. So what is Cauchy mean value theorem? So Cauchy mean value theorem, the statement says that here the two functions f of x and g of x. So f of x and g of x are the two functions. It is both are continuous in the closed interval a comma b, and both are differentiable in the open interval a comma b. Then the third condition is g dash of x is not equals to 0. So x belongs to a comma b. So then there exists a value c such that f dash of c divided by g dash of c is equals to f of b minus f of a divided by g of b minus g of a. So proof of this theorem is, so again let us define a function. Let us define a function. So that is also pi of x equals to f of x minus k into g of x. So k is appropriately chosen. So by data, so from the statement f of x and g of x are both are the continuous and differentiable functions. So f of x and g of x are continuous in closed interval a comma b and differentiable, and both are the differentiable in the open interval a comma b. So thus pi of x is also continuous. Pi of x is also continuous in closed interval a comma b, and also it is differentiable in open interval a comma b. So now suppose pi of a equals to pi of b. So that's from the Rolle's theorem. So from 1, so take it as a 1. From 1, f of a minus k into g of a equals to f of b minus k into g of b. So k into g of b minus k into g of a equals to f of b minus f of a. So k is common, g of b minus g of a equals to f of b minus f of a. So k is here only f of b minus f of a divided by g of b minus g of a. So k satisfy all the three conditions of the Rolle's theorem. So pi of x satisfies all three conditions of the Rolle's theorem. Hence there exists one value c, so that is belongs to a comma b, such that pi dash of c is equals to 0. So that implies from 1 f dash of c minus k into j dash of c equals to 0. So take it as a 2. So f dash of c equal to k into j dash of c. So k equal to f dash of c divided by j dash of c. So what is k value from the 2? From equation 2, so what is k value? F of b minus f of a divided by g of b minus g of a. So that is equals to f dash at c, g dash at c. Hence the theorem. So that can be written as f of c divided by g dash of c equals to f of b minus f of a divided by g of b minus g of a. So this is Cauchy mean value theorem. Hence, Cauchy's mean value theorem is proved. So in this class we discuss both the Lagrange's mean value theorem and Cauchy mean value theorem. So this is the proof for the Cauchy mean value theorem. Thank you.